So we're going to talk a little bit about data types, and in a programming language we have a set of data types that we can choose from when we declare our variables. So some of the common types are, let's just start off with integer, and integers let us store numbers from say 0 up to, well, let's say 32,767. But integers also let us store negative numbers, so we can store negative numbers, so we can store from, let's say, minus 32,768. You might think they're a bit sort of strange random values to pick to demonstrate what an integer variable can store. But these values are determined by how many bits we actually use to store this integer. So for instance, with this type of integer, we are storing these numbers in 16 bits. So we have 16 bits available in order to store our number. And 16 bits gives us this data range from minus 32,768 to positive 32,767. Now, depending on the computer, you might have 32 bits, which will give us a lot bigger value. One I can't remember off the top of my head, but you can easily find out what an integer that's 32 bits can store. It's something like 2 billion, or negative 2 billion to positive 2 billion and something. So that's an integer. So we have negative to positive, but we can also have an unsigned integer. And an unsigned integer is one that doesn't have a signed value. So that allows us to only store numbers which are from 0 up to the positive maximum of 65,535, I think it is, 65,535. Okay, so no negative values in there, but it does give us a bigger positive value. Okay, let's just, so we don't think that's 32-bit. So this is still a 16-bit integer. Okay, so unsigned integer gives us 0 to 65,535. So we can actually have integers or data types that store numbers which use less than 16 bits. So we could have a byte, which allows us to store from minus 128 up to, let's go 0 and then up to 127 positive. Okay, and that would be using 8 bits. And again, if we have an unsigned byte, okay, that gives us from 0 up to 255. Okay, and again, that's 8 bits. So, okay, so we've got unsigned integer, and signed integer, and unsigned byte and a signed byte. And you know, there are other variations on this, and depending on the programming language that you're using. So that's, if you like, whole numbers. Okay, so these are all storing whole numbers, be them positive or negative, but they're all whole numbers. Which is fine, but we don't only deal with whole numbers in the real world. There are different types of numbers. So if we wanted to store more realistic or some other types of numbers, we could use a data type called float. And the float data type allows us to store real numbers. And so real numbers are numbers that may contain a decimal point. So for instance, 1.85 or minus 1.85 or minus 39, so 40, minus 41, minus 0.00001384. Okay, so any of these sorts of numbers that are, have a decimal point in them, and they're still from very small numbers up to very large numbers. So have a look up at the float data type to see what sort of maximum numbers it can store. Now again, depending on the size of the float, how many bits it uses, decides on how many numbers it can store, or how big a variation of the numbers are. If floats don't provide you with a big enough number, you can use a double, which gives you or uses double the number of bits that a float does. So for instance, if a float was to use 32 bits, okay, then a double would use 64 bits. Okay, so it uses double the number of bits. That obviously gives you a bigger range, but it also means you're using twice as much memory, and depending on what you're doing with the double, it may not actually be as fast as working with a float. So you do have to make sure you pick the correct data type for the values that you want to store. If you're only storing whole numbers, there is little point in using a float data type, even though it may easily do what you want it to do. For instance, if you were storing age, you could have float age, and that could quite happily store pretty much any sort of number that you're going to use in there. But by doing this, if we're talking about age as just being in whole years, then what we don't want is for us to be able to set age to 89.35, okay, because we want it just to be in whole numbers. So if we did set it as a float data type, then we have this, it's not so much of a problem, but we have more flexibility, if you like, with the number, but we don't want that. It would be great if the computer could say, well, why are you storing it as 89.35? Because this is meant to just be whole numbers. So if we were to declare it as an int, and we try to do that, we would get a warning or an error in the compiler when the program was being built that told us that we couldn't do that. So that gives us some sort of built-in validation of the data type that we're storing. So choosing the correct data type gives us, or gives the program or the compiler the ability to check that we're not doing anything silly with the data that we've got stored in there. So some other types of data that we can store characters, and we can use a variable called char that allows us to store characters, and a character would just be a single letter, for instance A, B, it could be something like a character like a question mark or a hash sign or ampersands, these sorts of things. Chars can also store this. Okay, now this is, well, to you it probably looks like the number 1, but the number 1 stored as a character, or any number stored as a character, is different to storing it in an int. Okay, so instead of storing, let's go with age again. Okay, so storing age as an int, so storing the value 1 in a variable that's an int data type, is different to storing a char with this. Okay, so this is the character 1 and this is the number 1. This character, okay, is the ASCII code for the character 1, and if you look up in an ASCII table and find out what the ASCII value or the ASCII is for the character 1, which results in the value 49, I think it was. Hold on. Which results in the value of actually 49. Okay, so the ASCII value for the character 1 is actually the value 49. And when you look at data representation a little bit more, you'll see how these are actually stored differently. So just be careful that when you are storing chars, it is the character. Okay, it's the symbol, if you like. Okay, this is not the number 1 or the number 2. It's just this symbol that looks like the symbol for number 1. So chars, all well and good, but we can only store 1 char. Okay, so that makes it a bit difficult, because normally we want to store a list of chars or a string. So we can have some data types like a string, and a string lets you store a list of chars. And you see this time a string is actually in double quotes. Okay, and so strings are put into double quotes, and that allows us to store many characters. So lastly, we're just going to look at two things called, first one being a constant. Now, so far we've used variables. Now obviously a constant would seem to be completely different to a variable, as in a variable is something you can change, it varies. A constant stays the same. So we can use constants in a program, and we can set up constants, and they give us the ability to store a value which we don't want to change throughout the program. So let's say, for instance, we wanted a constant, okay, which didn't change. So in C we would use the keyword const, and we'll say int, okay, in this case. And so let's say we wanted to store something like something that's going to indicate a maximum value, and we'll say we'll give that the value of 30. So we've got a variable, or sorry, we've got a constant called max value, and we're giving it a value of 30. Now why would we want to do this? Well, it could be that this max value, say, indicates something within our program that may change at some point. For instance, it could be I don't know, the maximum number of cars in a car park, or the maximum speed a character can move, or something like that. But at some point this value may change. So it might be that the car park gets bigger, and we want to change the car park to be able to store, let's say 60 cars instead. So if we were to write our code, and everywhere we had, let's say we had a loop which went round and we always put in the actual value 30 rather than using our constant value, then if our loop changed, or if the number of car parking spaces changed, we'd have to go through all our code and change 30 from 30 to 60, which could take quite a while. We could do a search and replace, but that could change other things that are 30 and really mess things up. So instead of doing it this way, we could just use our const value instead. So instead of saying where I is less than or equal to 30, we'll say where I is less than or equal to max value. So I is plus plus. Okay, so this is a loop, or the start of a loop. So if we were to change max value from 30 to 60, we wouldn't have to change any other place of our code. This would automatically now loop around 60 times instead of 30 times, without us actually changing anything else apart from this here. So it makes it far easier for us to maintain the code like this, rather than having to go through and search and replace and change all the values in the code. And it also means we can't do anything else. We can't come along and say max value equals 40, because if we tried to do that, our compiler would call us, this would create an error, and it wouldn't allow us to do it, because it knows that this is a constant variable, okay, a constant, so we can't change it. And here we've just tried to change the value of their const, so we get an error. So it gives us that internal check-in, that extra validation that stops it going wrong. The other part of this is something called a literal. Literal just means we literally put the value into the code. So instead of putting something in a variable, it is just literally in the code. So if we had an equation or some sort of bit of maths where we said a equals 3 plus 5, here we've got two literals. Okay, they're literally typed into the code, and literals can be strings and chars as well as numbers. So when we're talking about a literal, it's actually the value. These are what we're saying. Okay, so we'll say this is literal. We could change that then, and put it as a value. Let's say count. So then we've got a literal plus what's in a value, a variable.